right, so let me now do another example. So here's another one. Now we want to find the GCF of this. I mean, even without what's written on the slide, from the previous slide, we should get that the GCF is 1. This kind of outlines why it would be so using an example. So here we have, again, we have a non-zero constant term, right? In other words, we have a term here with no variables, right? Or if you want, you can think of it this way. We have a non-zero constant term. That means m has to be 0, right? You could think of 1 as 1 times x to the 0, even though that's not really precise, but it's kind of a shortcut. So we get m has to be 0 in that GCF. And x to the 0 we could think of as 1. I mean, it's not precise, but again, it's just a sort of convention. For 4, 8, and 1, well, this again is really why your b here would have to be 1, mostly because the only factor of 1 is 1 itself. So the only possible common factor would have to be 1, as you can see. So that's really what it boils down to. So as you can see here, since we have a non-zero constant term of 1, that tells you right away that the GCF has to be 1. So if we were to factor this, we would have to do something else. The GCF would not help us. And how would you factor this? We will see later on a very neat technique to help us. But for now, let's focus on GCF. Okay, so now, actually, instead, let's move on to trinomials. Okay, for some reason, I thought I had another example of GCF, but I don't, but that's okay. I mean, I definitely will provide more examples because I know this stuff is not easy. But now we're going to look at how do you actually factor something that looks like this? Where capital B and capital C, you know, those are constants. Okay, notice that the leading coefficient here is 1. Okay, so if capital C is not 0, the GCF of this is going to be 1. What do we do? Well, they do go through more calculations in the textbook, but basically I did write out something here, but really it just boils down to finding two numbers, I called them little b and little d, whose product is capital B, no, excuse me, whose sum is capital B, and whose product is C. In other words, you want to fill in the blank, so to say. You want two numbers whose product is C and whose sum is B. Once you get it, you're gonna write out the factorization this way. I mean, I'm calling those numbers little b and little d. So again, you want two numbers whose product is C and the sum is B. Okay, let's consider an example. So suppose we have x squared plus 7x plus 10. Right away, you can see that, well, we have this trinomial, right? B, in this case, would be 7, right? C would be 10. We have three terms, right? We have a trinomial. The degree is 2. And the leading coefficient's 1. So we have three terms, degree 2, leading coefficient's 1. So we can factor this way. So we want two numbers whose product is 10, but the sum has to be 7. Now, without thinking, you might try, oh, well, let's do 10 and 1. But 10 and 1, as you can see, is not going to work. And why is that? Well, while 10 times 1 is 10, 10 plus 1, however, is not 7. All right, we're out of time, but let me just show you quickly that 5 and 2 are going to work. And I guess, you know what, we'll hate to stop here, but I guess we have to. It's 12:50, excuse me. So we'll stop here, and I'll continue next time. Okay?